let's know more about the data framing in asynchronous serial communication. So whatever the data that we will be sent, which is a character, which will be in the form of binary bits, it will be packed between the start bit and stop bit. The packing of data between the start bit and stop bit is called as framing. That is, a character will be placed between the start bit and stop bits. It's called as framing. So how many start bit and how many stop bits will be there? Generally, start bit will be always 1. Stop bit can be either 1 or 2. Start bit will be always a 0. Stop bits is always 1. And whenever the data will be sent, the least significant bit of the data will be sent first. So in the next coming slides, we will try to see one example we can understand in much more better way. Whenever in an 8051 serial port, there is no transmission, TXD line is held high. That is called as a mark. High is always called as a mark and low, that is 0, is always called as a space. Let's see with an example how the data framing will be done in serial communication. As I told, data framing is nothing but packing the data between a start bit and a stop bit. Generally, there will be one start bit and stop bit can be either 1 or 2. So let's see how exactly the character A will be framed. Whenever we have to pass the character A, its ASCII value will be considered. And the ASCII value of A is 65. And the binary equivalent of the same is 01000001. Let's see how this data, if it has to be sent, which will be packed between the start bit and stop bit. As it was told earlier, this data has to be packed between start bit and stop bit, right? Observe here, this is my data 01000001 and the lowest significant is D0 and the most significant bit is D7. This data is packed between a start bit and observe start bit is always a 0, right? And a stop bit, and stop bit will be always a 1. Fine. Observe, there is a no transmission here, hence there is a mark which is nothing but 1. There is a transmission here, hence there is a space which is nothing but 0. So now the character A has to be sent means it is packed between one start bit and one stop bit, and the value of the start bit is 0, value of the start bit is 1. When this has to be sent, first start bit will be sent, then least significant bit followed by the remaining bits, and the last bit will be the most significant bit and followed by the stop bit. Now whenever this data is being received at the receiving end, it will just remove the start bit, take the data from lowest significant bit followed by 7 more bits. So 8 bits, it understands that the 8 bits forms a required data and it removes of the stop bit. This is what exactly happened whenever the data is received at the receiving end. So all the characters will be considered with its ASCII value, and if we have to send a character, it will be packed between the start and the stop bit and then it will be sent. See, whenever I consider an ASCII value, we will be just consider the binary equivalent of that, which gives an 8-bit value. So along with 8-bit, we have one start bit, one stop bit. So together, how many bits we have now? 10 bits we have for each character. So whenever we add 2 more bits, it gives obviously 25% overhead. That is 8-bit character with an extra 2 bits, right? So in some systems, in order to maintain the data integrity is nothing but accuracy and the consistency of the data. To exactly know which is exactly the data which has been received and the data which has to be sent, one extra bits will be added, that is called as parity bit, right? It can be an odd parity or an even parity, and again this will be an optional. The UART chips in 8051 allows the programming of parity bit for odd, even and no parity. As I told, it can be of odd parity or an even parity, or we can have an option to not have any parity bit. If we have a parity bit, the data integrity will be increased. In order to achieve the data integrity, many a times we will be go for adding a parity bit, which can be an odd parity or it can be an even parity. This is how the data framing will be done in asynchronous serial communication in 8051.